Welcome to webinar about D1 Pay Service Integration. We hope it will be informative and cover all the necessary aspects, so you can start your development and integrate the D1 SDK. D1 Pay Prerequisites. Issuer Application Configuration. This slide provides an overview of the interaction and setup between the issuer and their issuer app when using the D1 SDK. Let's go step by step through the individual onboarding values required. On the right-hand side, you will find a table in blue of all the values we will provide you with during the onboarding phase. Often these values change when you go through the stages of your project. Naturally, for example, the D1 service URL is the same across all our customers for the sandbox environment. However, when you move forward to pre-prod or prod, this D1 service URL will be changed into an individual one for each customer. The other two tables in yellow describe onboarding and configuration values for which you are responsible. Important ones are the app PK you will retrieve and submit to us, or the different D1 Pay configuration values you will set. Examples of this are the payment experience you select for your end users, such as one-tap enabled or key validity period. We will explain all these different values in detail later, or they are described in our developer documentation when your developers are proceeding to integrate our SDK. To explain the left side, you will have to observe two mechanisms. First, in point 2, there is a configuration which is integrated into the app at build time. This would be the before-mentioned D1 service URL, which the SDK uses to call the API endpoints of the D1 backend. In green, you will find all activities occurring at runtime where such values as consumer ID or wallet configuration will need to be set for the D1 SDK to function properly. It is important to know that the consumer ID is required already during the D1 task.configure step, which initializes the SDK. Most importantly, this is a quick overview slide to help you understand what kind of values are involved in setting up your project both on the D1 backend and the SDK side. They are not exhaustive and can change, but should provide you with a good initial understanding. If you would like to study the visualization, then please pause the video now or come back to it later for further reference. Issuer Application Verification and Device Binding. This slide focuses on the importance of the app PK, DPO1, parameter provided by the issuer, which is used to verify that only authorized application owners can use the D1 Pay service. In the D1 Pay service context, the app PK refers to a SHA-256 hash of a public key extracted from the application signing certificate. This restricts the use of the D1 Pay service only to issuers authorized by our company. The issuer integrator is expected to retrieve the app PK value by means of one of the available options described in the developer portal and provide it to our backend integrator. The value is used when configuring the issuer's tenant of the D1 Pay service on D1 backend. Please be aware that an invalid or missing app PK parameter value will lead to SDK configuration failure and all further use cases will be blocked. After the onboarding phase is done, the application should be signed at build time. Then the issuer application should send the register consumer request to the issuer backend. The issuer backend will return consumer ID. After that, the application creates D1 task to initialize all necessary settings for D1 SDK. The next step is for the application to provide the consumer ID in D1 task configure call to configure D1 SDK together with D1 Pay configuration parameters. Then, if it is the first call of D1 task and configure after the application installation, D1 SDK will retrieve app PK and generate the wallet ID. In the next step, the D1 SDK will call wallet secure enrollment towards D1 backend to receive secure assets and initialize an internal crypto box bound to the application instance. If it is not the first call after application installation, the application is ready to use D1 SDK after the successful callback. Issuer Application Push Messaging Service Registration. Push notification delivery is essential for supporting SDK functionality such as lifecycle management, card digitization, or key replenishment. You need to choose between using Firebase Cloud Messaging Service or Huawei Messaging PushKit. Your application has to support at least one of these solutions. As a prerequisite, the SDK needs to be properly initialized. So at the beginning of the process, the FCM API key must be shared with our integration team. Then all the received parameters are deployed in the app at build time. Next, to be then able to receive notifications from D1 backend, the issuer application must retrieve the token from FCM or HMS. After retrieving the token, the issuer application registers the obtained token to the D1 SDK using the update push token method. D1 SDK then submits this token to D1 backend server. D1 pay flows. Digital card enrollment. Digital card enrollment consists of two steps. The first is to check card digitization state and the second is the card digitization itself. Enrollment experience. Here you can see the typical UX of the digital card enrollment flow with the D1 Pay service. One important difference compared to OEM wallets such as Google Pay, Apple Pay and Samsung Pay is that the issuer is in charge of all the steps and can completely control the UX. The whole process is driven by two buttons. The first button is for enabling NFC payment, illustrated here on the card selection screenshot. This is, in general, the starting point of the process. And then you have an indication button that you can use to disable the NFC feature, as illustrated on the NFC. Payment is ready. Screenshot. Check card digitization state. Let us start with the flow on how to check the card digitization state. It is important because the card state can have multiple values. To check the card digitization state, your application has to trigger D1 SDK using Get Card Digitization State API and provide the card ID. Based on the received card ID, the SDK retrieves the card data information from D1 server. In case of success, D1 SDK returns to the application one of the following states: digitized, not digitized and digitization in progress. In case the application received digitized, then you will hide the button. For not digitized state, you will show the button. For in progress state, you need to wait. It means, the digitization has started but has not yet finished. Card digitization 1. After retrieving the card digitization state, you can start the card digitization flow, specifically to add a digital card for a given card ID to D1 SDK. Then the D1 SDK initiates tokenization. It communicates with the D1 server, which then sends the check eligibility and card digitization request to Visa or MasterCard server. In case of success, the scheme TSP returns a token consumer ID, token profile, and payment keys. It is worth mentioning that when the callback is received, it means that TSP has created the digital card and SDK is ready to securely provision the digital card. It was not yet provisioned into the device. Now, let us go through the process of provisioning the digital card into the app. It is initiated by an incoming push message. Then Process Notification API processes the pushed data received from the notification server. And the SDK receives command data from D1 server. The app should wait for the on-data changed callback, indicating that the card is in active state. If this is the first card, it will be automatically set as the default card for payment. Also note that for MasterCard tokens, the app will receive two push messages. Contactless payments. Payment experience configuration options. The diagram is summarizing the available payment experience configuration options and should guide the customer to decide what payment experience you will deploy. CDCVM stands for Consumer Device Cardholder Verification Method. Basically, that means the end user's phone is used as a terminal for inputs to provide verification. Traditionally, with the well-known plastic debit or credit cards, the end user presents their card to an electronic payment terminal. The payment procedure is initialized usually by the store entering the payment amount into the device and presenting it to the store customer. Next, payment information from the end user's plastic card chip or mag stripe is transmitted by swiping, inserting or tapping to the physical payment terminal device. Lastly, once communication has been established with Visa or MasterCard, a PIN will be requested to be entered via the payment terminal device for authentication. With our D1 solution, this authentication is now performed on the end user's phone instead of the payment terminal. For this authentication step, our D1 solution provides various configuration options due to risk assessment requirements of the issuing bank, country regulations or desired user journeys. Let's start at the top of this diagram where you will have to decide if you want to support consumer device cardholder verification. If you are not, then tapping an end user's phone to a payment terminal device will behave just like a plastic card. That means a PIN will have to be entered via the payment terminal to authorize payment. However, if you would like to allow for a better user experience, then we will continue with the yes path to the next decision point of either always or flexible authentication. Simply put, with always, the end users will have to authenticate themselves every time they tap their phones to make a payment. The default behavior is the CDCVM always and one tap enabled where simple phone unlock is sufficient. To restrict the window, since when the phone screen needs to be unlocked, an authentication validity period can be configured. Authentication validity corresponds to unlocking the device screen with fingerprint, pattern or PIN. The default period is 45 seconds in which the user can unlock their own device screen with whatever method the phone supports and pay within the specified window without extra authentication as well. If phone screen unlock as authentication is not desired, this will result in requiring the two-tap flow. Here the user taps the first time to initiate the payment, then gets prompted a screen on his phone to authorize the transaction via PIN etc. and then has to tap again to complete the transaction attempt. On the other hand, with flexible authentication, payments become much more user-friendly. So-called low-value transactions will be approved automatically up to pre-configured maximum values. This means the end user can walk into a store and pay for small sums without having to authenticate explicitly. Naturally, this raises questions of fraud, but they are taken care of with maximum cumulative low-value amounts which can be integrated into your risk assessment. Furthermore, transit experience and authentication validity period can be configured. The transit experience allows for seamless payments when entering a mass transit system where the authentication is simply approved. Contacting Visa or MasterCard does take a second or two, which no one wants to wait for at a walk-through gate. Additionally, these values are all set within your domestic currency and will be automatically converted into other currencies if the end user travels abroad on the D1 backend. This way, locally set restrictions apply globally. Lastly, it is important to know that with all the presented authorization types, the payment terminal is the only device with knowledge of success or failure of the payment. The payment terminal communicates with Visa or MasterCard to confirm the payment was made and usually prints out a paper receipt for record keeping. The phone and thereby the D1 SDK has no idea if the payment was made successfully after the NFC tap, as there is no further communication. That is especially important as you will be showing a success screen that the payment attempt has been executed correctly but not the payment itself. Preparing the device and application for payments. Let's review the list of device and application requirements that need to be fulfilled so that the application can process contactless payments. First, it is mandatory that the device is equipped with a near-field communication (NFC) hardware interface and its software supports host card emulation. Next, the NFC interface needs to be enabled. This is a user-controlled setting. but the application could check the state programmatically. On some specific devices, there is also a setting defining routing of the communication received on the NFC interface. It should be set to HCE wallet, in case that such setting is present. The last device-level setting that needs to be present is a secure unlock method, which is required for user authentication when performing payments. Those are usually PIN, pattern or biometric authentication. The application needs to meet additional requirements, so it will be able to process contactless payments. It has to define a host APDU service in its manifest and provide additional service resource files. On the other hand, it does not need to implement such a service as the implementation is provided by the D1 SDK. Next, the application has to request the user to confirm setting its payment service as the default one. Only then the app will be invoked when the device is tapped on a payment terminal. The last step for getting the app ready for contactless payments is the digital card enrollment, as we have seen previously. In case that multiple digital cards have been enrolled, the application has to make sure that an active card is set as the default with respect to D1 SDK. We encourage you to review further details in the D1 developer portal. Payment flows, one tap. This slide visually demonstrates the one-tap flow. The end user, also referred to as the consumer here, must authenticate before tapping the payment terminal. This usually must occur within the CDC-VM validity period, which is set to a default of 45 seconds. As described before, this validity period checks how long ago the device was unlocked and treats this unlocking step of the screen as a valid authentication for a certain time window. After tapping the payment terminal, the SDK will trigger a callback to display a success message. This message only confirms that the payment execution between the point of sale, POS, and the device has been successfully completed, but it does not indicate that the payment has been authorized yet. To receive an authorization result, the payment terminal needs to connect to the payment network to reach the TSP and the issuing bank for a sufficient funds check, among other things. We will show the individual events in the next slide. In this slide, all the individual events are described. Please note that in step 3, the risk evaluation has an effect on the user experience. Especially, low-value transactions can be performed quickly if enabled by the issuing bank. All taps are performed offline, and the payment terminal goes online to authorize the payment after the app has signaled completion. Please pause the presentation now if you wish to study this slide further, or you can come back to it in the future. Payment flows, 2-tap. This slide illustrates the 2-tap flows which invoke additional authentication. The first tap initializes the authentication. This can occur under various circumstances, such as when the validity period has exceeded its limit since screen unlock, the device has exceeded its maximum values for cumulative amount or counter for low-value transactions, or even due to the CDC-VM always requirement. As you can see, after the first tap to the payment terminal, the users are prompted to authenticate. Our developer documentation explains which authentication methods are accepted at this stage. Next, on successful authentication against the device and therefore the SDK, a second tap to the payment terminal needs to be performed to conclude the payment execution. In the next slide, we will describe all the events in detail again. As you can see, the process is a little more complicated compared to the one-tap flow. However, what's most important is the nature of risk evaluation in step 3 and that all of this is happening offline, as before. Please pause the presentation now if you wish to study this slide further, or you can come back to it in the future. Payment flows, manual mode. This payment flow is different from the 1 or 2 tap solution. Here, the user first needs to select the payment application, in this case, the issuer app, to launch into the NFC payment activity. That means tapping to a payment terminal device will cause no response initially without manual intervention. The flow will go as follows. First, the user selects the payment activity. Then he will authenticate himself and then tap to the payment terminal device within the specified time limit. Naturally, this is not the best user experience and therefore not recommended for implementation. In the next slide we will describe all the events in detail again. In this slide, you can see all the events related to manual mode payment. Most interesting here is the first step, where you need to supply a card ID and call the Start Manual Mode Payment method from somewhere in your app. Please pause the presentation now if you wish to study this slide further, or you can come back to it in the future. Digital Card Lifecycle Management. Digital Card Lifecycle Update from Issuer App. This slide illustrates how a digital card lifecycle update could be requested. From the beginning, the Issuer app calls D1 Pay Wallet.update digital card with parameter card ID and D1 Pay digital card. The digital card is received from Get Digital Card or Get Digital Card List API. Also, you need to specify the card action to be performed: delete, suspend or resume. After that, when the callback is triggered by the SDK, the digital card's lifecycle is not yet updated. It only signals that the command is sent successfully to the server. The digital card's lifecycle update starts when the application receives a push message. After the application receives the push message, the process notification call processes the push data received from the notification server. The final status update is received through the D1 Pay Data Changed listener. Digital Card Replenishment. Digital Card Payment Key Features. This slide highlights the distinct behavior exhibited by keys based on the respective payment schemes they belong to. As you can see, Visa uses limited use key abbreviated as LUC, where one key is used for a limited number of transactions during a limited time period. That means the key comes with a max payments parameter. You can set it up, for example, for up to 10 transactions. And the expiry date, which equals the date of provisioning plus the time to live received from Visa Token Service. MasterCard's digital card uses a single-use key abbreviated as Consumer SUK. One key is expended for each transaction. The digital card is provided with a set of SUKs. Due to MasterCard's security design, one SUK is also discarded every time the digital card is unset from being the default. Check if digital card needs replenishment. This slide illustrates how to check if the digital card needs replenishment. To do that, you need to call two APIs. Firstly, call Get Digital Card API, providing card consumer ID to obtain a D1 Pay digital card. Then call is Replenishment Needed API. It returns whether replenishment is needed, returning true or false. Replenishment of a Visa digital card. This slide describes how to execute replenishment for a Visa digital card after you receive confirmation that it is required. As a first step, call Replenish API based on the card ID. The SDK forwards this request to the D1 server that will send it to Visa. After Visa receives this request, it sends a new limited use key back to the D1 server, which securely provisions the key to the D1 SDK. For Visa cards, the replenishment is done synchronously. This means that the digital card will be replenished after the replenish callback is triggered. Replenishment of a MasterCard digital card. We already went through the Visa replenishment. Now let us see how this process is executed for MasterCard. You again call Replenish API based on the card ID. The SDK forwards this request to the D1 server, which will send it to MasterCard. After MasterCard receives this request, it sends new single-use keys back to the D1 server, which in turn sends a push message to the issuer application. Then the application should call Process Notification API, providing the data from the push message to the D1 SDK. For MasterCard, replenishment is done asynchronously. which means that the replenishment callback only indicates that the request was accepted, but the actual update is signaled by the onDataChangedListener method in step 7. D1 Pay, Visa Digital Card Replenishment. This slide illustrates additional flows for Visa replenishment. The first flow is the authentication during replenishment. This flow occurs when the Visa digital card's limited use key is getting close to its expiration date, but the digital card has never been used for payment. In this case, the application should call D1 Pay Digital Card. Is authentication required before replenishment API to authenticate the user during replenishment flow and then call replenish method. The second flow is ODA key replenishment. ODA stands for offline data authentication. The Visa card with this type of authentication has its own expiration date. In this case, the application should call D1 Pay Digital Card. ISODA replenishment needed API and then call the replenish ODA method. D1 Pay, replenishment check and trigger entry points. This slide provides a recommendation on how to integrate the replenishment check and trigger it depending on the payment scheme. In general, trigger the replenishment only if the SDK reports it is needed or if it is forced by an incoming push message. For Visa, please trigger replenishment when the limited use key expired or when it is close to expiration. Also, trigger replenishment when the ODA key expires. We also recommend triggering replenishment after each transaction using the onNextTransactionReady callback. For MasterCard, please trigger replenishment after the default digital card is changed for the application with multiple MasterCard digital cards. Additionally, we recommend triggering replenishment after each transaction using the onNextTransactionReady callback. Troubleshooting. Troubleshooting, issue reporting. When encountering issues with our D1 solution, we would like to ask you to report this issue in the following way. First, please describe which use case was executed, such as login or card digitization. Second, please let us know your expected result of executing this use case. This will enable us to be on the same page when discussing the designed behavior of the product. Lastly, please share with us the actual result or error details as complete as possible. Often, we will inquire about logs from you to understand the entire flow which leads you to this point. We will talk about how to obtain the logs in another slide soon. Troubleshooting, contextual data. To help us understand your error quickly, we also ask for contextual data such as timestamps, issuer ID, or other IDs to filter our logs. In other cases, we might ask you for data you have generated such as the JWT to compare to what the D1 backend is expecting for successful API calls. Finally, for D1 Pay specifically, the wallet ID and digital card ID are of relevance. The wallet ID identifies the actual application instance running on a device, whereas the digital card ID uniquely identifies the card used in this particular wallet. Troubleshooting, obtaining device logs. To obtain the device logs, we first have to determine in which mode the SDK is currently running. There is debug and production mode. In debug mode, the SDK will allow direct output to the logcar in case of Android or console on iOS to show all API calls, data received and success and error messages. We will usually request these logs during the onboarding phase where you integrate the SDK into your application and go through testing milestones to verify the correct functionality. Once you are live with your product, the SDK will run in production mode, and no logs will be printed locally. In this case, you will use Secure Log to retrieve the logs from your device and send them to the integration team. The integration team will then decrypt these logs and help you understand where the error originates. How to obtain secure logs is described in our developer portal in detail. Next steps. Thank you very much for attending this D1 SDK workshop webinar. We hope we answered most of your questions, and you found this information helpful. We encourage you to go through our developer portal pages to understand the solution in more detail. The next phases on your D1 solution integration project should be discovery, onboarding, integration, testing, and then launch. You will be guided through this journey by our team of specialists and a project manager. We will do our best to make your integration smooth and trouble-free. Thanks for selecting us as your service provider.